Welcome back, friends. Today we are going to solve problem 144 of LeetCode binary tree pre-order traversal, as well as the next problem binary tree post-order traversal. So these problems with binary trees, pre-order, post-order, in order, these are problems are very important problems from the perspective of any interviews, and this is very important concept to understand about a binary tree. So after this working session you will understand how we can do pre-order and post-order traversal of a tree. I will be explaining using a good example how we can do the traversals, and we will write the Java solution for the same. So before we start looking the details of the problem, I want to mention that I often create LeetCode solutions for LeetCode problems using Java, as well as helpful interview material videos, for like which discusses what Java questions are important from perspective of interviews and how to answer them, and discusses different topics with Java. So please subscribe to the channel. The subscription is really helpful to the channel to grow, and I can reach out to more people with this channel. So let's look the details of this problem now. So they have given us a binary tree, and we have to do the pre-order and post-order traversal. So they have created like a sample class tree node. So tree node will have a value. For example, this one is a tree node here, and it will have a value, and it will have a left and right child, right? Left and right children it will have. It's a binary tree. So let's discuss how the pre-order and post-order traversal works with this example here. So let's start with first the pre-order traversal we will do for this tree. So pre-order traversal always we always visit the root node first in pre-order traversal, and then we visit the left subtree and then right subtree, right? So always root is first in pre-order traversal. So let's start with this root here. So root is 25, so 25 we will visit first, so 25 here. Then left subtree means we will start with this whole big subtree, right? This is the left subtree, as you can see. We will finish this, and after we finish the left subtree, then we will start with this right subtree of this root, right? So now let's start with the left subtree. So now from 25 we will go to 15. So we first visit always the root of the subtree. So 15 we will visit, then we will again go to left, we will visit 10. So we will have 10 here, again we will go to left, now we will visit 4 here, so we'll put a 4 here. Now we don't have anything to go after 4, right? Left child is null, right child is null, so we will visit the right subtree of 10 here, right? So 10 right subtree will be 12, so you can see 12 is here. Then after that this subtree of 15, right? This left subtree is complete, so we will start looking the right subtree of 15. So we will go to right subtree from 15 here, so we go to 22, so 22 is here. After 22 we will go to left again, so 18 will be there, so 18 is here. Then we will go to right again, so 24 will be there, right? So 24 is there. So similarly we can go to, now our left subtree of 25 root is complete. Now we have to go to the right subtree, so we will start looking into right subtree now. So we will go here 50, then we will go to left, so it's 35, so 35, then 31 left side, and then 44 right side, so 31 and 44. Then here again we will go to now right side here, so 70, first always root, right? And then left and then right, then again left 66, 66, and right is 90, so 90. So this is a pre-order traversal of this tree, right? Pre-order traversal we have seen here. So let's just quickly, I'll just show you how to implement the pre-order traversal. We are going to use a recursion to implement it. So first I created a list of integer array list, because that's what we have to return back, and we are going to pass a root here to our recursive pre-order function, and the result, which is the list, basically array list. So here first base condition we will check if it is node is equal to null, we have to return, right? We cannot do anything after that basically once we reach a null node, so we will just return here, right? And since it is a pre-order traversal, right, first always we will visit the root, so that's what we are visiting here. So means we are adding it to our result first, and then we will recursively visit left node of that node and right side of that node basically. So left subtree here and right subtree here, so automatically it will call recursively and it will create the pre-order traversal for us. So let's take a look at this use cases, and let's make sure that this code is working. So our code is getting accepted and we are getting the output correctly. So we will submit this code for pre-order traversal. So our code is 100% and 0 ms, so this is very fast. So now we will see the post order traversal, right? In the post order traversal it is almost like very similar to pre-order traversal. The only difference in post order traversal is we first visit left and right subtrees, and then at the last we visit the root, right? So let's just let me take this thing again back out. So now we will try, now this is the post order we will look, right? So now we are visiting 25 but we are not processing it, right? We just visit it, then we will have to first process the left subtree, right, before we process the root. So that's what the post order is. So here we will go left subtree and then the root, right? So left subtree again, 15 means again we have to first process the left subtree, again we will go here, again we will from 10 we will have to again go process first left subtree and right subtree, and then we will process the root, right? So we reach here, so we will process now this node. So it is coming here because now we cannot go left and right, so we will go back and we will process the right subtree here, which is 12. So 12 we process, and then at the end we are processing our root, right? We are processing our root here. So that's why it is post order traversal. So similarly we will again from 15 we will have to now we have done with this left subtree of 15, right? Now we have to first to do the right subtree of 15. So now what we will do is we will go here. So 22 means we will not process 22, right? We have to first go left, so we will go left. Now we will process 18 first, so 18 came, then we will go right, so 24, so 24 will come here. Then after we are done we can process the root because we process the left and right subtrees. Now 22, and then after 22 is done, now for 15 we have processed the left subtree, this one, and this is the right subtree, so we process both. Now we can process the root node 15 here, right? So 15 came here. So you have to just do it like continuously. Now then you will continue on this side, the right side, and then at the end once you are done with this, finally we will process 25. So at the end you will see the 25 is coming right here. So this is the post order traversal. So post order means first we will process the left subtree completely, then right subtree completely, and then the root node, you know. So that is what the post order traversal means. So again we are using the recursion here for implementation. It is very similar to the pre-order traversal that we have. So we have again a recursive function. We will check if node is null, then we will just return. Otherwise first now we want to process the left subtree, right, and then right subtree. So that's what we will first recursively call left subtree here of the root, then right subtree here, and once that is done then we will process the root node here, right? So that's what the post order traversal means. So let's just take all the use cases that they have and make sure it's running correctly with all different combinations. So our solution is getting accepted here, so let's submit this. So our solution got 100% and 0 ms, so it's very fast. So recursive solution are generally very fast. So this is a easy way you can do pre-order and post-order traversal for binary trees. So as I mentioned, earlier, I often create LeetCode Java solutions and Java J2E interview related materials, as well as I already have created playlist for LeetCode as well as some computer science concepts like DFS, BFS, dynamic programming, linked list, hash map. So please check out the playlist. It has a lot of good stuff, and subscribe it to my channel now. Like subscription is important. So thanks for watching the video.